can learn interesting things from reading government reports. The Soviet Union invented the concept of stealth aircraft in 1962, but the math was incredibly hard. They couldn't do it with slide rules in 1962. The math was intractable. So they didn't think it was technologically practicable to design such an aircraft, and so they didn't think it was worth classifying the idea. They published the idea in the open literature, and later on an American aeronautical engineer read the article and realized what it meant. The US took the idea and kind of ran with it. They didn't have very fast computers in 1981, so you got the low poly count version. But by 1989, they had much faster computers. They could do the math and solve the equations. So you got the high polygon count version. This is literally how it happened. Okay, so I ran across this article. It was published in Warsaw just a few weeks ago about cybersecurity of 3D printers. The authors are Polish army researchers, which is interesting because it gives you an idea of the kind of thing other governments might be interested in as well. 3D printers use servo motors or steppers to move a print head along orthogonal X, Y, and Z axes. There are at least 3 motors in this contraption, pretty hefty ones, and they make noise, either acoustically or in the radio frequency spectrum. If you've ever listened to a scanner, you know the sound of these stepper motors or servo motors when they're running. They make kind of a whining noise. And the motion of the motors is somewhat predictable because you know that it has to remain within the envelope of the 3D printing volume. So the authors of this paper wanted to know if you could deduce remotely what a 3D printer was making just by listening to it. Now, if you can keep track of the position of the printhead in 3-dimensional space, then by integrating its position over time, you can figure out the shape that's being made. This is a picture of another kind of 3D printer designed by a company called Revolution Space. They're working on 3D printing an entire space rocket from the engine nozzle on up in one piece. 3D printers are not all fidget spinners and toy dragon statues. They are being used for some serious applications. And this has intelligence gathering applications. You do this kind of measurement in an anechoic chamber where the background noise level is around -40 dB. The same researchers also measured the fluctuating magnetic fields around a 3D printer while it worked. The math is not that far off from a CAT scan, so it's definitely tractable. The frequency range that they found to contain most of the information was 11 to 23 kilohertz. This is the library of test shapes that the researchers used. And this is an acoustic spectrogram of the sound made by a 3D printer when it was printing the triangular prism shape. Here are some side-by-side spectrograms showing the sounds made by the 3D printer when it was printing a triangular prism, a square, and a round tube. The method works on horizontal and vertical surfaces, or any angle in between. It works on curves, and interestingly, it can handle voids. Extension of the method to any arbitrary 3-dimensional object is pretty clear. You can see that these spectrograms are definitely distinguishable, and you can tell the difference between curves, straight lines, horizontal and vertical. So the researchers are currently working on automatically recognizing any arbitrary shape being made by a 3D printer. The agreement between the model and the observation, the model is in black, the observations are in red, is remarkable. They They proved that this works. If you want to look up the original information, these are the references, and I'll put my slides up on the website in PDF format so that you can look them up if you want. But that's it. Gabe, I'll give it back to you.
Great, that's cool. We've tried applause in the past. It doesn't work so great on Zoom, but you can press the little reaction button and there's an applause icon there. So click that, and you can give some virtual applause. They're not quite as satisfying as real applause from the whole room, but
thank
works
you.
a little bit better. So thank you, Joe.
Short talk today, but this is not my research. This is something that somebody else did.
Very cool. Questions?
Have you seen the Unreal 5 engine preview? It reminds me of the polygons. They're talking about how they're doing millions of triangles in their new rendering engine. And
yeah, that was a joke. But when I saw the picture of Lara Croft, I couldn't resist. But that is literally what happened. They could only, in 1981, they could only do the math for a small number of polygonal flat surfaces. And by 1989, they had much faster computers and they could calculate curved surfaces, which is what all stealth aircraft use now.
That's interesting.
That's cool.
Yeah, it makes you think about what advances like that will be able to do in 10 years from now. Doesn't seem like there's a lot of compute limited problems around, but there must be some.
Well, I wish somebody would give a talk on the simulation hypothesis and attempts to hack into the computational substructure of the universe.
Sounds good. Maybe we'll find a speaker who specializes in that.
Yeah, you should note that the number of subatomic particles in the observable universe is about 10 to the 82nd, which is real close to 2 to the 256th power, suggesting that the universe runs on a 256-bit architecture.